Good evening, ma'am.
Good evening. Good evening. Could you complete all the worksheets?
Ma'am, I completed some of them. I was also doing the miscellaneous exercises.
Until the others join us, so let us recall what we did in the last class. And I'll just test you on distribution and let's see whether you are okay with the distributions. Let A be the set 1, 2, 3, 4, 5, 6. Two numbers are chosen. Two numbers are chosen 1 by 1. 1 by 1 without replace. Capital X denotes the bigger of the numbers. Find the probability distribution of X.
Good evening, ma'am.
Good evening, Jessica. X denotes bigger of the numbers. Bigger of the numbers chosen. Just to test whether you have gone through probability. Of course, we are going to do the first 4 chapters today. Just one sample. Want to know whether you're thorough with the distribution concept. Be able to see, otherwise you can be seated here. Could anyone complete? So, can someone tell me first of all, how many possibilities will be there totally? You're choosing
30.
very good, very good. Yeah, totally there'll be 30 possibilities. What is the reason? You're choosing two numbers, right? The first number can be chosen in 6 ways, but the second number can't be that. No, because you are choosing one by one without replacement. So the second number ought to be chosen in 5 ways. So totally, how many ways? 30 possibilities are there. So can someone tell me what are the possible values for capital X? What does capital X denote?
The bigger number.
Ah, very good. Yeah. Capital X denotes the bigger of the two numbers, right? So what can it be?
Two,
For
three,
example,
four,
I
six,
get the output as 1 and 2. Then capital X will denote 2. Do you all agree? So whatever might be the outcome, it can't take the value 1 because 1 will be always smaller of the numbers chosen. Whatever pair that you may get, I may get 6, 1, I may get 4, 1, I may get 1, 3, whatever. But 1 can't be that number. 1 can't be that bigger number. So what can be the bigger number? Can the bigger number be 2? Depends. Of course, in one of the possibilities, it is one of the values. For example, 1, 2 is the outcome.
Yeah.
2 will be your
X.
X. So X can be 2. It can't be 1 for sure, but it can be 2, it can be 3, it can be 4, it can be 5, it can be 6. Do you all agree? I think the only thing that we miss out is 1. It can't be 1. It can be the rest. So let us understand that only these are the values taken by X. So this clarity, okay, if you have this kind of a clarity as to what are the values taken by X, the main job is over. So what are the values taken? How many values are taken by X? X takes 5 values. Do you all agree?
Yes.
X takes possibly 5 values. So X can be 2, X can be 3. That's what we have agreed. All of us have agreed that X can take only these values. What is the meaning of this? When do we say that X has taken the value 2? I get some outcome and I say that X has taken the value 2. That means what did I get?
1.
I got something.
1.
Yeah, very good. Either I got 1, 2, or I must have got 2, 1. In both the cases, I will say capital X is 2, right? So that is the meaning of X taking the value 2. Always remember, like I told you in the last class, when X takes the value, some numerical value, it is referring to some sample point or a group of sample points. What are those sample points? We have to investigate. Okay. So let us understand what is meant by X taking the value 3. It can be. When do you say that 3 is the bigger number? What should be your outcome? Very good, very good. You got it. Yeah, excellent. 1, 3. All these, no? 2, 3 and 3, 2. Understood? How about 4? When do you say 4 is the bigger number? 1, 4, 4, 1. 2, 4, 4, 2. In all these cases, no? Or it can even be 3, 4, 4, 3. Did you see every time we seem to increase the possibilities? So when x takes the value 2, only 2 sample points were there. But when x was 3, 4 sample points arose. How about x being 5? It can be due to 1, 5, 5, 1. Or it can be due to 2, 5, 5, 2. It can be due to the outcome being 3, 5 and 5, 3. Or it can be due to 4, 5 and 5, 4. Right? But for 6, again, number should increase. I've understood the logic, no? So if this yielded 8 points, they should yield 10 points, right? So 1, 6, etc., etc. Should I elaborate? All of you know, isn't it? So it can be up to 6, 5. So 10 points will be there, right? So what are the corresponding probabilities? That's what is very important for us. Of course, we have understood the meaning. Now we should write the corresponding probabilities of these. Okay. Can you help me in that? How do I write? Because that is what is known as probability distribution, isn't it? A distribution refers to what? Values taken by x in the first row. And in the second row, what should I write? I should write the corresponding probabilities. Okay. So who is going to help me in this? 2, 3, 4, 5, 6. These are the values taken by x. So what are the corresponding probabilities? How many sample points came under this? 2 sample points came. Out of possible,
30.
how many were there in the sample space?
30.
30, very good. So 2 by 30. Understood? That's all. We have to have a clear understanding of the sample space. We should know how many sample points arise for each of the corresponding values of x. We should find the possible values of x in the first place. After that, we should know how many sample points are supporting this value. After that, we should write the probability. That's all. Very simple. 4 by 30. 6 by 30. Every time it increases by 2, right? So these are the values. So did I get a legitimate probability distribution? How do I know? How do I know that I'm right?
Sum of all the probabilities is
Very good. We can sum it up. We can sum up the second row and convince ourselves that it is indeed legitimate. Let us add up 10 plus 8, 18 plus 6, 24, 24 plus 4, 28. I'm adding numerator, okay? 28 plus 2, 30. Understood? So I got the total sample points. So 30 by 30. So sigma of pi happened to be 30 by 30, which is 1. Of course, I'm very happy that overall my distribution is fine. Okay. Of course, I might have, gone wrong somewhere here or there, and I must have, or I must have got something less and something more. All that you have to be careful about. But overall, I'm feeling fine because my sigma pi turned out to be 1. Are you okay with the distribution? How many of you got this correct without even my, help? Very good. Excellent. Very good, very good. All right. So you seem to be all right with somewhat distributions. And let us pass on to, briefly I'll recall all the valid points that you should know. Because the first 4 topics, in these topics only, many MCQs come. Do you all know that? In these 4 topics only, MCQs come mostly, and therefore you should be thorough with all the possible concepts. So let us start from basic itself. R from A to B is called a relation. It's called a relation if it associates the elements of A with elements of B by using some rule or condition. Some rule or condition will be imposed, okay, by your relation. And whichever set of elements or pairs of elements satisfy that condition, they'll be put in that R. Okay, that is our understanding. This is broadly the idea. Okay, so by means of a relation, what do? I connect or I associate the elements of the first set with the elements of the second set by means of some rule imposed by me, right? That's what I do broadly. So, or in other words, what happens is that here R is therefore becoming a set of ordered pairs, one taken from the first set, another taken from the second set, such that A is somewhat related to B. Can be anything. It can be equal to, it can be greater than, it can be a friend of, it can be a wife of, whatever. This relation can be anything. This is something that you impose, okay, depending on the kind of sets that you are dealing with. That is broadly the way relation is defined. We either say that R is this, a set of ordered pairs such that A related to B, such that A is definitely from capital A and B is from B. This is the way we define R. Or R can also be defined like this. A is related to B if A is equal to B, something like that. Okay. So there are two notations for the relation I'm saying. A relation from A to B can be defined explicitly as a set of ordered pairs, okay? Or it can be just descriptive like this, A related to B if and only if A is equal to B. We can also say it like this, no? Both mean the same. Are you all aware that both are equivalent? But here, while discussing about equivalence relations, we'll be dealing with only relations which are defined from one set to itself, no? R is related to, from A to, R is defined from A to A itself. In this case, R can be defined as AB such that some A less than B, or it can be defined as A related to B if and only if A is less than B. Both are equal. Understood? Okay, so this is the way we define R. Now the question arises as to how many relations are possible? How many relations are possible from A to A? This is one of the important questions. How many relations are possible from A to A if n of A is, say, n. Number of elements in A is n. In the sense, I have, say, your A is A1, A2, etc., An. What is your understanding? There are n elements there, right? So I have such a set, and I want to find out how many possible relations are there. One is to, anyone who has got the answer? How many relations are possible from A to A? 2 power? Very good. 2 power n square. Okay. Why? Because R is basically a subset. No? R is basically a subset of A cross A. Because it contains ordered pairs, and ordered pairs are invariably there in the parent set A cross A. So R must be a subset of A cross A. And number of elements in A cross A is nothing but n of A into n of A. That is nothing but n square. And therefore, the possible subsets of A cross A will be 2 power n square. Therefore, there are totally 2 power n square relations possible. Okay, this is one way of understanding the total number of relations from A to A. But there is another way of understanding this using the concept of permutations, combinations, see, what is your R? R is made of ordered pairs, right? Like I have n elements here, n elements there. So I can create ordered pairs here, no? In this matrix, I can create all possible ordered pairs like A1, 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 A2, etc. A1, AN, right? So similarly, I can create AN, A1, etc., etc., AN, A. So how many elements are there in this matrix? How many elements are there in this matrix? Who's going to tell me? Huh? What order is this matrix? N cross N. So how many elements will be there? N square elements. Okay. So each of these elements will either come or they won't come in R. There are two ways. There are two ways in which all these N square elements can come or not come. Okay. So that means what? There are two ways of having this. There are two ways of having this, etc., etc. So what are the total possibilities? 2 into 2 into 2. How many times? N square times. So 2 power N. Understood or not? So total possibility, because all these ordered pairs will either come in your R or they may not come in your R, depending upon the way you define R, right? So there are 2 power n square ways in which your R can be defined. Try to understand this way of finding the number of elements in R. Later on, it will be useful for us to investigate certain other things. Have you all understood this? There are totally n square elements.
You gave it in the equivalence worksheet.
Yeah, I gave it already, but I'm just recalling. So the total number of subsets of A cross A is 2 power n square. But let us turn our attention now to the reflexive relation. How many reflexive relations will be possible? All that we'll discuss. What is a reflexive relation? Because some of you are very good in understanding. I have no doubt. Many of you are very brilliant. But how you write it, that's what counts, no? Examiner will look at only your answer. Okay, she won't know. I know all of you are very brilliant, but for them to know, you should write. Okay, so let's say someone wants to define a reflex relation. What do you do? Because you'll have to substantiate something, no, in the exam. How do you write? R from A to A is reflexive. Let me see who writes it very well. Reflexive is
If X belonging to A can be written as X comma X, and X comma X ordered pair belongs to R. I mean, I've written it in this manner.
That's what I'm saying. That's what I'm saying. All of you can, but I want a very precise and perfect definition. Who's going to say? Very good. She got it. XX belongs to R. This is what follows is very crucial. For all X
belongs to A.
belonging to A. Okay, because many students go wrong here. They will say XX belongs to R for all X belonging to R,
A,
which is ridiculous. No?
R is a subset of A.
Yeah. R is a subset of A cross A. That's why it contains ordered pairs, all right. R contains ordered pairs, but those elements are taken from the set on which R is defined, isn't it? So get this right. Otherwise,
Mom, instead of putting that for all, you can just put that B and strike it. You can just flex in front of examiner that you know.
oh, okay. So this will do. Okay, this should do. Similarly, there is another possibility, sometimes your R is defined from a cross product to another cross product. In that case, how will it be reflective? It is reflexive if, can someone complete? The elements are not taken from A. The elements are all taken from set of ordered pairs. Elements are ordered pairs. Your R is ordered pair, but now your R is ordered pair of ordered pairs. Okay, that's the difference. In this case, how do you test reflexivity? If AB related to AB for all AB belonging to A. Understood? This is the way we define reflexivity. In case R is defined in what? Ordered pairs. Set of ordered pairs. the sense usually it is defined on set that contains elements, but those elements can be ordered pairs themselves. In that case, the way to check reflexivity would be this. Okay. So next question arises as to how many reflexive relations can be there. If R is defined from A to A and A contains n elements. In that case, how many reflexive relations are possible? Can someone answer this?
2 power
Possible.
n to n minus
Uh,
2 power n into n minus 1.
2 power n square minus n. Very good. Possible reflexive relations will be 2 power n square minus n. So will you remember this? What is the logic? What is the logic for saying that there will be these many reflexive relations? The thing is, that's why I wanted you to remember this. See, what is meant by a reflexive relation? It should contain all the diagonal entries, no? Like A1, A1, A2, A2. All those must be contained in this. Totally, there are n square elements, among which diagonal entries are n. Okay, so what are the non-diagonal entries in this? Diagonal entries are total how many? Totally n square. Okay. How many diagonal? Diagonal is n. So what are the non-diagonal entries? N square minus n. Okay. So the non-diagonal entries will come or not come. But all the diagonal entries will definitely come. So they come with possibility 1. Okay. They can be chosen in one way. But non-diagonal entries can be chosen in 2 ways. Okay. So 2 into 2 into 2. Number of non-diagonal entries times. That is nothing but 2 power n square minus n. So these many reflexive relations are possible. Have you understood this? Okay. Now turning our attention to symmetric. Symmetric relations. Are from, define it probably, we can have it from you. Is symmetric if
X1, X2, X2 plus 1 belongs to R for X plus 1.
yeah, we can also take AB, isn't it? If AB belongs to R, implies BA belongs to R. Can you complete for all?
X comma y belongs to R.
Very A comma belonging to, for AB, for all AB belonging to R. Understood? So get it right, all of you. For all AB belonging to R, we must have BA belonging to R. Or in other words, what do we do here? In order to prove symmetry, what do? We assume that AB is in R. Given AB is in R. To prove that BA is in R. That is the task. Okay. Or in other words, we are just checking whenever I swap the roles of A and B, whether there is any impact or not, or still the relation is maintained or not. That's what I check, right? And say R is defined from n cross n to n cross n. In this case, how will you check symmetry? Is symmetric if
AB or CD is equal to B.
AB related to CD implies CD related to AB. For all AB, comma CD belonging to n cross n. Belonging to R. Get this right. Take down the definition properly. Whenever AB is related to CD, we should show that CD is related to AB. How do you go about it? Assume that AB is related to CD. You get some algebraic equation. Then you have to prove that CD is related to AB, get that algebraic equation 2, call that as number 2. So you have to prove number 2, making use of number 1. Understood? Okay. So how many possible symmetric relations are there? Who knows? Number of possible symmetric relations. Who remembers?
2 power n square plus n by 2.
Huh? What
2
is it?
power n square plus n by 2.
2 power n square plus n by 2. Very good, Subhitra. Yeah, it's correct. But how? How is that? What are the non-diagonal entries? What are the non-diagonal entries in that? N square minus n, right? But half of them I take. For half of them, whenever they come, okay, whenever they come, the other should come, isn't it? So for example, suppose the non-diagonal entry is some 1, 2. 1 has to be there, right? How about the diagonal entries? The diagonal entries can come or need not, isn't it? Because it's not about reflexivity, no? So if we add these two, what do you get? You get n square minus plus n. Understood this logic? So this is, I think she gave a brilliant answer. So these are the possible symmetric relations. Understood, all of you? How about transitive? Tell me how you would define transitive relation. A related to B, whenever, okay? The botheration arises only when you find this. A related to B, B related to C should imply A related to C for all A, B, B, C belonging to okay, in case of R is defined from n cross n to n cross n. Okay, in that case, how do you check transitive relation? AB related to CD, okay, as well as CD related to EF should mean that AB is related to CD. For all AB, CD, EF belonging to n cross n. Understood? So then we know that the equivalence relation is 1. That which is reflexive, transitive, symmetric in that order, no? Symmetric as well as transitive. That is what the equivalence relation is. So how do I find out how many equivalence relations are possible when I'm given the number of elements in the set? For example, suppose the set A has 1 element. How many equivalence relations are possible? Number of equivalence relations. Can someone tell me? The set A has 1 element. How many equivalence relations are possible?
1.
1. Suppose if it has 2.
2.
2. How do you get that actually? What happens is that, so the previous row had 1, isn't it? So I should write it here. And then add these two numbers and write it here. You understand what I'm doing? For constructing the next row, write the last number. What is it? 2. Okay. Then you should add these two, write it here. Add these two, write it here. Then you will get the number of equivalence relations for 3. How many of you understood so far? Did you understand what I'm doing? You didn't? No, what I did was, I took the first row. The set had one element. I have only one equivalence relation. What is that? For example, your set has the single element A. How many equivalence relations are possible? It has to be this, right? Is it not equivalence relation by default? So there is only one equivalence relation when there is a single element. So to find out how many are there in the set with two elements, I write what was there in the previous row, in the second row. Then there is a scope for adding. Do you see? Because there are two elements here. 1 plus 1, I write that here, which is 2. To find out how many are there, equivalence relations are there in a set with 3 elements, I write this last number here. Okay. Can you add now? 2 plus 1, 3. Can you add now? You can. Okay. So do you understand the logic? What will be the next number in the next row? 5. Very good. The last number. Okay. Is there a scope for adding? Yes. 7. Is there scope for adding? Yes. 10. Is there scope for adding? Yes. 50. So that is the number of equivalence relations for 4. Can you construct and show me for 5? How many? First copy down this and then tell. The last number depicts the number of equivalence relations. Did anyone get it? What should you write first? You tell me. The next row, what should I write first? The last 15. Is there a scope for adding? Number above 20. 20 plus 7, 27. 27 plus 10, 37. 37 plus 15, 15. These many equivalence relations are possible with set having 5 elements. Because total possibilities will be 2 power 5 square. It's a large number. Amongst them, only 52 will be equivalence relations. Understood? Totally many possible relations will be there, but not all of them will be equal. These are called Bell numbers. The Bell numbers actually tell us how many equivalence relations are there. Number of them. This stands for number of elements in A. Okay, the first column. Second column stands for what? The last entry there stands for number of equivalence relations. So when they give you small numbers, it will be possible for you to write. For example, if they say the set has 3 elements, how many possible equivalence relations are there? 5. I think that's all they can ask. All these 15 and 52 will be too much, for you to calculate. But the logic behind this is very interesting to find out how many possible equivalence relations, the number of ways of partitioning the given number of elements. In partitioning is nothing but having to do some distribution with the given set of elements in various baskets. I'll tell you whenever time permits, probably later on. Okay. So shall I test you with one thing? Okay. R from set of human beings to set of human beings. And R is defined as XY such that X and Y have same height. Okay. This is the first relation that I'm taking. What's your take in this? We can have several equalities here. If X and Y have the same IQ, if they have the same weight, if they live within, if they work in the same office, anything. Yeah, all these are very good examples of a very, very smooth relation. What is so special about this relation? X and Y have same height, so I think this will be reflexive because X and X will have same height. And symmetry also will be maintained. X and Y
Yes.
have same height, so Y and X will be having same height. X and Y have same height. Y and Z have same height. As a relation, as a result, your X and Z also have same height, and therefore it is transitive also. Therefore, it is equivalence. So my question is actually not that. Suppose I take an element, some element here, say some capital A. Okay. A is some element belonging to H. That means A is a person. Say this human being is nothing but this class, say this class of students. I take one of the students, A. Okay. What is his equivalence class? That's what I am interested in. What is the equivalence class of A? Who's A? A is a student, right? A is a student belonging to the class H.
If it belongs to class E,
What is
belong
his
to
equivalence class?
A and itself belong to the class.
A is a
A-
member of that class, member of the class.
Member
But
of the class.
I want the equivalence class of A. Meaning, who knows? What is meant by equivalence class?
People
This
on
is
the
an
same height
equivalence
as it.
relation. This is an equivalence. R is equivalence relation, no doubt. That's a different thing. I want the equivalence class of A. Equivalence class of
Subset of all elements that are equivalent to each other. Subset of all elements that are equivalent to each other in that relation.
very good. Yeah, it's somewhat right, but I want more clarity. Anyone?
It is a subset.
It is a set, actually. I understand. It is a set. Okay, so what did you say, Nisha? Okay, say Sahana belongs to this class. The equivalence class of Sahana would be all those students who have her height. In the sense, they will all be related to you or not. Okay, so you will be creating an equivalence class like that. You understand what I mean? So the equivalence class for Rakshita would be all those students who have the same height as she does, right? So how do I put it in words? I'm asking. X such that X is related to A. Understood? All of you understood this concept is a very important concept. That means what? Or in other words, X and A have same height. That's why X is related to A, right? You understand or not? All those, human beings or all those classmates who have the same height as A, they will be found in the equivalence class of A. You understand that? Similarly, I can find the equivalence class of B. That will be what? X such that X is related to B and X is a member of that H. That is a condition. It must be taken from the set on which it is defined, obviously. So this is known as equivalence class. Are you okay with this? Now let us take it because equivalence class is where many of you can't actually answer properly. That's what I found from your test. So R is defined from the set of real numbers to real numbers. And R is nothing but XY such that some relation I'm taking. Is an irrational number. Some relation. It's an irrational number. See whether it is equivalence or not. X and Y are real numbers, right? But I want X minus Y plus root 3 to be irrational. Okay. Is it reflexive?
Yes, ma'am.
Very good. Yeah. it will be reflexive because x minus x plus root 3 is irrational. How do I test reflexivity? I replace y by x. Y is no longer there in the picture. Okay, I replace y by x and I test the validity of the statement. X minus x plus root 3 is irrational, makes sense to me. Therefore, I'm saying it is reflexive. How about symmetry?
Yes, ma'am.
Yes. Ma'am, it's
No,
not
It's
symmetric.
not
Very
symmetric.
good. Ah, very good. Yeah, yeah. Can you give me a counter example? I think
1 and root
Um,
3.
yeah, she gave a very good example, not symmetric because root 3 comma 1 will belong to R, but 1 comma root 3 will not belong to R. Counter example will be actually enough. No, but if they give you this problem, ask you to find whether it's an equivalence relation or not. And if you say that it's not symmetric and wind up your solution there itself, I think there is some lacuna there. You need to think about the transitivity also. Can someone tell me counter example for transitivity? Okay, we definitely know that 1, 3 is not in R, isn't it? 1 root 3 is not there. So, okay. Construct now. In between, anything can be had such that this 1x, x3 should be 1x comma x root 3 should be in R, but 1 root 3 we know already it's not in R. No? So can you give some value in between? How
2
about
root 3.
1 itself? Huh?
2 root
Two?
3.
2 and 2. Just check the validity. Understood all of you? So not transit.
Ma'am,
Not-
but 2 comma root 3 cannot belong in
Ma'am,
R.
we can take root 2 instead.
Yeah. Yeah, that's a good idea. Yeah, anything that, yeah, it's nice that you pointed out. Good job. Because they should be there, no, without them being there, it is, absurd to think about all this. So 1 root 2 should be there in R, root 2, root 3 should be there in R, but 1 root 3 is not there in R, and therefore it is not transit. But here we can't talk about equivalence relation, isn't it? So let us take some other equivalence relation. Okay, so maybe such that AB related to CD if and only if AD is equal to BC. I just wanted to reinforce certain ideas where I think you're weak. That's why I'm taking these problems. So because I've seen several of your performances, so I think these are the areas that need to be addressed. So AD is equal to BC. Okay, this is how your relation is defined. Is it reflexive? Is it reflexive in the sense I'm asking, is AB related to AB? What do you think? Yes?
Yes.
So when are they related? If the product of the extremes is the product of the middle. Yeah, that is true. Okay, so reflexive. Okay, let's assume that let AB be related to CD. Will that give me, can it give me the fact that CD is related to AB? That's what we are testing, no, in symmetry. First is reflexivity, second is symmetry. In this, that's what I'm discussing. So that means what? I'm given AD is equal to BC. I'm just checking, does it imply that BC is equal to AD? Is it true? Yeah, actually 1 and 2 are one and the same, right? 1 and 2 are one and the same. In fact, 1 is nothing but 2, or 1 implies to 2. or the truth of one, justifies the truth of two. Okay. Therefore, 1 and 2 is not independently true. That's what you have to remember. Okay. The truth of 2 depends on validity of 1. Right? Understood? Therefore, 1 implies 2. Therefore, it is what? Symmetric. Okay. Third one, the transitivity part. In that, we'll assume that AB related to CD. We have 2 truth equations here. Okay. Because I'm assuming a series of truth equations. Okay. Or in other words, I'm assuming that AD is already BC given by equation 1. I'm also assuming CF is D and I'm calling it as 2. And I'm investigating whether these two, validity of these two, will prove a fresh equation where I demand that AB should be related to EF. Or in other words, I'm investigating whether AF is equal to BE, which is needed to establish this, call this as 3, whether it is arising from 1 and 2. Of course, I'm not trying to prove this independently. Remember, the truth of this is not taken for granted. Making use of 1 and 2 only, I should prove this. So this is in question now. Okay, this is under suspension. I need to prove that actually. Okay, but making use of 1 and 2, somehow I should prove the truth of T. So I can do anything I want with 1 and 2. What do you plan to do? What should you do? Obvious.
Divide.
1 into 2. If you do 1 into 2. Because both 1 and 2 are true by themselves. So if you do anything with them, the outcome should be fine. Okay. So ADCF should be equal to BCDE. So what happens with the common element CD gets cancelled and I get precisely what I want. I mean, the equation that I'm looking for. Okay. So 3 is true, hence proved. Hence proved what? Hence proved it is transitive. So it is reflexive, symmetric, and transitive, therefore. So many students know at the time of conclusion, they will say, therefore, it is an equivalence relation. See, it's all in your mind. How will they read it? You have to say it's an equivalence relation because it is. Of course, some of you write like professors, you write so many detailed justifications, but at least when it is needed, you have to write it, no? Because it is, don't forget this, reflexive, symmetric, and transitive. All of you understood? My botheration is actually, how do I find out the equivalence class? Okay, after establishing equivalence relations only, we can think of equivalence classes. Always remember, equivalence classes arise only when there is an established equivalence relation. Okay, then only we can find the equivalence class of any element on which your R is defined. Okay, find the equivalence class of any element. For example, I want the equivalence class of 2, 5. Suppose they say 2, 5. Find the equivalence class of 2. So how do you begin this? Let me see. There are some bright students in this class. So let me know how they will approach this problem.
Ma'am, A comma B is 2 comma.
So the equivalence, so you should begin like this, no? The equivalence class of 2, 5 is given by set. Complete, Aparna? Set. It's always a set. Do you all know that? What is that? Again, it will be an ordered pair only, some XY only, such that all those elements which are related, like I told you, no, in the previous equivalence class.
A or B.
What did we have in the previous equivalence class? I wanted the equivalence class of A. Then I wanted all those elements, all those students who are related to A. Right? That is only the equivalence class of A. Correct? So what will be the equivalence class of this then? What are the equivalence classes? All those elements which are Very good. It should be related to this. That is the condition. Now tell me how many of you understood this equivalence class, because that's bothering me every time. Many of you flop in this. That's why. Let me know if you have understood. Equivalence class is nothing but set of elements which are all related to the given element. Very simple. Okay, let us try and understand the nature of X and Y further. We need to, actually, this is the basic concept, but you should say what it is. No? What kind of XY, ordered pairs XY are related to 2, 5, I should say. That means, that is, what does this mean? The extremes should be this, right? Or in other words, 5x should be 2y. Elements such that 5x is equal to 2y. Or elements such that x is equal to 2y. Understood? So I can say this in a better manner now. Okay, because I've understood what kind of elements will now be related to that 2, 5. Okay, so what should I say? X, y such that x is equal to 2 by 5y. Okay, where x and y are, we should not forget what these x and y are, right? What are they? What are x and y?
Natural numbers.
Very good, very good. See, she's not losing focus. X and y are natural numbers. No, because your R is defined on n cross n. So your x and y, xy is an ordered pair in n cross n. That means your x and y are natural numbers. Understood? So this is how we depict the equivalence class. Okay. Okay, what is the role of equivalence class, or why is it important to learn equivalence class? This I've told you in one of the earlier classes. Let me see who remembers. What is the important property of the equivalence class?
They are disjoint.
Very good. All the equivalence classes will be disjoint. Yeah. Even last year in the board exam, they asked this question. So one of the MCQs, the properties of the equivalence class. Okay. After that, they are mutually disjoint.
Union of those forms the equivalence equation.
Very good. The union of those equivalence classes will bring about
The entire set.
the entire set on which your R is defined. Okay, suppose E1, E2, that's what they described in the previous MCQs. E1, E2, etc. En are equivalence classes. And then he had given some choices. Okay, where he mentioned that EI intersection EJ is null for every I and J. Is it true or not? There's nothing common. No, they're all disjoint. That's what they said. No, that's the property. This is true. Remember, these are the important properties of the equivalence classes. They will be pairwise disjoint. Okay, one more, he said. What did he say? One more, Anirudh. What did he say? E1?
Union.
And E2. If you unify all these, you should get
Relation R.
the set A on which your R is defined. Understood? So I think we have discussed relations to some extent. Okay. And then, of course, we'll be doing a paper in which, again, all these will be recalled. So that time I'll know whether you understood or not. So now let us pass on to functions. Functions also, I find some bit of misunderstanding or not perceiving things properly in certain aspects. Okay, basically, function, all of you should remember, okay? Say there is a mirror here. I stand before this mirror, okay? And my friend also stands, okay? Both of us stand before the mirror. And both of us see a single image, but is it normal to have this situation? It's a mirror actually, no? Both of us stand, but both of us should be there, no? Provided the, mirror is long enough. It should accommodate both of us. Instead, it is giving only one image. This is called not one-to-one. Two distinct elements, I and my friend. Okay, both of us have the same image. This is called what? Not one-to-one. Understood? Suppose, okay, I can also describe another thing. Say there is a mirror. I alone stand. Okay, I alone stand. This mirror is so faulty that it shows two images for me. Okay. How about this mirror? How about this mirror?
Not a
That
function.
was a not one-to-one mirror.
It's not
This
in a
is
function.
not even a function. Yeah, this is such a stupid mirror that it's not a function at all. Because for one person, it is showing two images. Observe, no? I'll be having a severe jolt, no? Yeah, early in the morning, if I stand before the mirror and I see two images, something is wrong with my eyesight, or this mirror is terribly wrong. Okay, so we are not thinking of such mirrors. Okay, we are only considering mirrors that have only one image for one person. But this mirror shows for two persons, it is showing same image. So such a function is called what? Not one-to-one. That means what is the nature of the one-to-one function? When I have two distinct elements, their images should not be same. Understood? This is the condition for one-to-one function. Remember this. When x1 is not equal to x2, I must have their images also should be distinct. That is the condition for one-to-oneness. Okay. But this condition is popularly remembered as f of x1 is equal to f of x2 should mean x1 is equal to x2. And therefore, this is turning out to be the test for one-to-oneness. This is the definition of one-to-oneness. And the definition of one-to-oneness is actually turning out to be the test for one-to-oneness. Okay, so it is authentically, actually, it is authentically saying what? It is just reinforcing your definition. So another way of saying the definition, we can say old wine in a new bottle, because this is more elegant. So this has turned out to be what? The test for one-to-oneness. Nice. So you can go to the middle room. So test for one-to-oneness is this, right? Okay, this is how I establish one-to-oneness. Test for one-to-oneness is what? It's meant for establishing one-to-oneness. So how do I prove that something is not one-to-one? If you want to prove that something is not one-to-one, just take two elements, x1 and x2. For x1 and x2 belonging to A, show that f of x1 and f of x2 are same. If we can prove that, then you are establishing that it is not one-to-one, isn't it? You understand this? Not really.
Little confused. I'm little confused. How?
Okay, very
how does the
popular.
test for one-to-one relate to this right now? I'm little confused because if you show that it has a pre-image, then it
No,
is
I
one-to-one.
took two distinct elements, but I'm showing that their images are same. Precisely this situation. Okay, this is me. Okay, this is my friend. Okay, but our images are same.
x1 equal to x2 equal to 1.
F of x1 and f of x2 are same. That's when it's not one-to-one, isn't it? For example, f from R to R, f of x is x squared. Okay. What is f of minus 1? That is plus 1. Or minus 2 you take. F of minus 2 is plus 4. And f of 2 is also plus 4. So what does it mean? Therefore?
They are not one-to-one.
Yeah. Minus 2 and plus 2 have same image. This is what we are objecting to. No, this is actually destroying the nature of one-to-oneness itself. No, same image. What is that image? 4. Therefore, not 1-to. Understood? See, establishing something to be not 1-to-1 is very simple. I just have to think of 2 elements in the domain and prove that their image, 2 distinct elements I have to take. And if I somehow prove that their images are same, I'll be establishing that it is not 1-to. Proving something to be 1-to-1 only calls for what? Effort. I'll give you an example. Suppose f from R to R. Okay. And f of x is x by 1 plus x. Will this be 1-to-1 or not? Can you try? Can you try and tell me? Okay, what's your conclusion? Is it 1-to-1 or not?
1-to-1.
Huh?
1-to-1.
1-to-1. Are you
Because
sure?
I took it
No,
as
ma'am.
which one is
Huh?
good and which
Anirudh says no. Okay.
No,
How many of
ma'am.
you say no? Yeah, many of you. Very good. Very good side. Okay, let's see. Let's see what makes you say it's not 1-to. And there should be some justification. No. Of course, it's very difficult to think of counter examples in such cases. So we have to go the proper way. Okay. Let's subject it to test. Okay. Let f of x1 be f of x2. So x1 by 1 plus x1 square is x2 by 1 plus x2 square. And let me cross multiply. I get x1 plus x1 x2 square is equal to x2 plus x2 x1 square. After that, just bring the terms to the left in a conducive manner so that it will be possible for you to write. Yeah. Congrats to Dhira. He became the outstanding student. X1 minus x2. I'm grouping the linear terms together. Okay. So x1 minus x2 plus x1 x2 into x2 minus x. Understood? After that, what is common? X1 minus x2 is common. I can take it out. Did you do all these? Or I don't know how you are simply saying that it's 1-to-1. Because I get 2 possibilities. Either x1 minus x2 is 0, or I get 1 minus x1 x2 is 0 as well. Okay, the first one is leading me to the thing that I want. I want to establish that x1 is equal to x2. No. But apart from that, I seem to get one more possibility. No. x1, x2 is 1. This is also possible, right? It's also possible because what are x1 and x2? They are real numbers. So product of 2 real numbers can be 1. Yeah, provided they are not zeros. So all the real numbers will have the reciprocals. Except 0, all the other numbers will have reciprocals. So that means all non-zero numbers will have trouble here. Okay, like reciprocals of each other. For example, your f of half and f of 2 may be the same. I think that's why it's causing trouble. What's your function? What's your f of x? X by 1 plus x. So you should proceed properly and only then you should conclude. Okay. What is this? Tell me. Half by 5 by 4. What is it? 2 by 5. 2 by 5. Keep it. F of 2 is. Oh, that's also 2 by 5. Did you see?
Okay.
Both are fetching same thing. If I had been intuitive, probably I would have said initially just by looking at the problem. It's not so easy. But there are some brilliant students who may say half and 2 will have same image, so it's not 1-to-1. But to say that in the very first place, you need to be brilliant. So you don't have to be brilliant. If you are systematic, that's enough. Just subject it to this test. This test is ultimate test for 1-to-1ness. So if it's going to yield x1 is equal to x2 alone as the possible solution, the domain, see, domain is the concern for establishing 1-to-1ness. Range is the concern for establishing onto. Okay. So let us pass onto now. Are you convinced it's not 1-to-1? Okay, onto. Okay, bring clarity. F from A to B is onto. By the way, we didn't discuss how many 1-to-1 functions are possible from A to B. Anyone? F is from A to B. How many 1-to-1 functions are there?
N factorial.
How many 1-to-1 functions from A to B? This is my question. Assuming that N of A is some L, N of B is some M. Okay. Of course, here M has to be greater than or equal to L. Say, for example, suppose my A has 2 elements and B has just 1 element. This will be hopelessly 1-to-1. Isn't it? I mean, hopelessly not 1-to-1. See, look at this. It's exactly what we are objecting to know. Two things having the same image is a terrible function which is not 1-to-1, right? So when the number of elements in B is less than number of elements in A, 1-to-1ness can't be established. You understand that basic fact? So M must be more than L. So the number of 1-to-1 functions from A to B will be anyone?
M for L.
Is it NCM into M? factorial?
Very good. Yeah, I think Nishant got it. B. In case the number of elements in A and B are same, then it will become factorial, n factorial. For example, both A and B have n elements. Number of 1-to-1 functions will become npn, which is nothing but n factorial. That's also precisely the number of onto as well as bijective functions from A to B. Are you okay with this generic formula?
Yes.
Suppose both of them have the same number, then it will become npn, which will be nothing but n factorial. Understood, all of you? Okay, number of 1-to-1 functions. Okay, going to onto-ness. Onto or surjective, no, both mean the same. 1-to-1 or injective. Onto or surjective. F from A to B is onto if, who's going to say authentically, which is the best way of testing onto?
Equal to codomain.
Yeah. Codomain and range should be same. Range is equal to codomain. So we must find the range and establish that to be the codomain. Or a function can be made onto by reconstructing your B or having B altered as your range, because range is after all a subset of the codomain. So if you remove all the unwanted elements in B which do not have pre-images, then you have the B sized down to a smaller subset, and therefore it will become onto. Okay, so it's very easy to make some function onto by altering your codomain. All right. So now let's take the function that we had defined earlier on and test if it is. And how to establish something is not onto. Not onto. Establishing onto is by establishing range is equal to codomain. It will be not onto if an element in B does not have pre-image. Okay, any element. If we can point out a single element in B which does not have a pre-image in the domain, you are through. That is the power of counter examples. counter examples can dispel huge castles also. Okay, so not onto if an element in B does not have any range. So this is the way to establish ontoness. Range must be proved to be codomain. It wouldn't be onto if an element in B does not have a pre-image. Okay, so go ahead. There are two ways of example one. What do you think is this function? Is it onto or not?
Not on.
Not
onto, ma'am.
Right? You can see when you strongly feel something is not onto, you can give a counter example, right?
Negative
Tell
number.
me which one in the codomain will not have a pre-image?
Negative numbers.
Negative number.
Very good. All negative numbers. Okay. -1 belonging to codomain. Codomain is R only, no? -1 belonging to codomain R does not have pre-image. That is enough. They will accept it. They'll accept it with all reverence because this is enough. Because what is the underlying reason? Because x square minus 1 is absurd. That's why. Understood? In the place of f of x, put that element and see whether it makes sense or not. It doesn't. And therefore, it's not having pre-image. Whichever element you think is not having the pre-image, put that in f of x and solve for x. If f of x is absurd or if x is not belonging to your domain, then you are correct. Your intuition has worked. You understood, all of you? Whichever element is not having pre-image, whatever you think, you put it in f of x and solve for x. And then you should establish such an x does not exist in the domain. You have to. Understood? So this is a simple way of, or if you want to go the conventional way, find the range of this. The range of, what is the range of f of x? Range of f of x is nothing but the range of x square. But you know that the square of any number will be always positive. So it's nothing but 0 to infinity. But that's not equal to codomain R. Okay. Therefore, not onto. You understand? You can either establish this way or this way. Both have equal merit. But I think those who do by this, they'll be saving a lot of time. No? And also sometimes, you know, your intuition for the range is in question. Okay. Like, okay, in the second example, example 2, can you arrive at the range? Example 2, f from R to R, and f of x is x by 1 plus x square. Can you arrive at the range of this function? Let me see who's good at it. Or you can give a counter example too. Either way, I don't mind, but you have to tell me whether it's onto or not.
It's not onto.
Very good.
It's not on to.
Yeah. I know most of you feel that way, but you have to give a suitable counter example for this.
I equated it to y and found the discriminant, and the range came to be -1/2 to 1/2. It's not the codomain.
Good job. Yeah, that's a very authentic way. Yeah. Other than that, did you try the counter
We can take a
example?
negative. We can take a negative rational number, like -3/5, and then try to find x. And
Even
then
I
if it's
think
not like,
something as simple as 1.
Mm.
You can also take 1, I think. I strongly feel that 1 is a culprit. Okay, if I feel that 1 is a culprit, let f of x be 1. Okay, put that culprit in the place of f of x. So 1 plus x square, cross multiply. So I get 1 plus x square minus x is 0. Let me shuffle this. 1 minus x plus x square, or let me put x square in the first place. How about its discriminant of this quadratic? B square minus 4AC. 1 minus 4 minus 3. Okay, less than 0, no? Discriminant is less than 0. So what is the nature of the roots?
Complex.
Complex. Understood? So x is not real. This is less than 0. X is not real. Therefore, x does not belong to the domain R. Domain is R, right? X is not belonging to the domain R. So what is the conclusion, essentially? We took this number 1 in place of f of x, but we couldn't find a suitable x for it. So that means what? Therefore, what should you write? Therefore, 1 does not have, very good. 1 belonging to the codomain. I took 1 from the codomain. I put it in the place of f of x, and I solved for x, and I was for a shock. I had a shock. What shock did I have? X became complex, and x was not in the domain, right? So 1 does not have pre-image. Therefore, not on. Yeah, this is one way of intuitively saying. But suppose, on the other hand, they had altered and given already, okay? They had given the range as the coordinate.
Just on to.
Then it's not possible for you to take any counter example, 1 or anything. Like Asmeda, Jessica said, you can take minus some numbers, she said. All those won't be possible because he has restricted the codomain to be this. But how do you establish your range to be codomain? You have to work your way.
Equate to y.
Yeah. See, because y is x by 1 plus x square. I should find the range means what? I should find the values of y. No? So I have no other go. I can't give counter examples now because he has trapped me. He has given the codomain to be range itself, and he is testing whether I'm able to find the range. In that case, what should I do? I should cross multiply. I'll get yx square plus y minus x is equal to 0, or yx square minus x plus y is 0. Okay, but I need the condition that x must be real. Okay, therefore my condition for that is b square minus 4ac is greater than or equal to 0, right? What is b square here? B is minus 1, okay? A is y, c is y. This must be greater than or equal to 0. Or in other words, 1 minus 4y square should be greater than 0. Or 4y square minus 1 is less than or equal to 0. Or let me factorize this. 2y minus 1 into 2y plus 1 is less than or equal to 0. You should do all these declarations in the exam. Otherwise, they won't agree. Okay. So y belongs to minus half plus half. How many of you know when you come across a quadratic inequality like this, okay, immediate solution is the closed interval. Okay, take down this. Okay, because that is what is justifying the statement. And therefore, range is this. Copy down the way we have found out the range, which is equal to codomain. And therefore, we can confidently now say, therefore, it is onto. But however, it's not bijective. Did you see? Because it wasn't 1-to-1. Earlier, we had seen that 2.5 had the same image for this function. But I think those who are very intuitive will always know whether the function is onto or 1-to-1. For 1-to-1, you have to give counter example by taking values from the domain. Okay, you have to take 2 values from the domain and show that they have the same image. And for producing counter example for onto-ness, or when you're establishing it's not onto, you have to take an element in the codomain and put it in the place of f of x and show that the values that you get for x are not in the domain. That's the way to, smash your bijectiveness. Because when it's not onto or 1-to-1, it won't be bijective, isn't it? Sometimes they ask for pre-images. Find the pre-image of something. What do you do? Find F inverse of, say, suppose they say find F inverse of half, or they say find the pre-image of half. What would you do? Find the pre-image. Also find the pre-image of 1 by 3. This can be something that they can give you. What is your functional form? F of x is equal to x by 1 plus x square, right? Okay. In this, I want the pre-image for 1 by 3. Meaning, where is my 1 by 3 now? It is in the codomain, no? So anything in the codomain, I have to put it in f of x, right?
By
So 1
3 is
by
x
3
by-
is equal to x by 1 plus x square, and I have to solve this. Hope you understand. Solve for x. I think maybe. What do you get? I'm cross multiplying. I'm getting something like this. I can factorize this, but it'll be hard. Okay, so what I do, I think it has real roots. So minus b plus or minus root of
Ma'am,
b
it comes
square
to
minus 4ac by 2a. Okay, so x can be either 3 plus or minus, either 3 plus root 5 by 2 or 3 minus. These are the prefixes. Have you understood? Can an element have two pre-images? Is it fine to have that way? Are both these in the domain or not? They are real, right? 3 plus root 5 by 2, 3 minus root 5 by 2. That again establishes what? That it is not 1 to 1, isn't it? Because for both these values, I get the image to be 1 by 3. So again, it's not 1 to 1. So it is just re-establishing that. Understood, all of you? Okay, so what is the bijective function? Bijective function is something that it is, yeah, if it is 1 to 1, a function which is 1 to 1 and onto is bijective, right? What is the advantage of some function being bijective? Or why at all should we establish some function to be bijective? What is the advantage?
So we have an inverse.
Very, yeah. So necessary and sufficient condition for f to have an inverse. Only then the inverse function, say from f is defined from a to b, the inverse function of f will be defined from b to a. Okay. So f inverse exists. Okay, how many bijective functions are there? Number of bijective functions when f is defined from a to b and n of a is equal to n. Say there are n elements in a. Will be? Who's going to complete? Do you know that for finite sets, to establish bijectivity between them, the number of elements should be necessarily same, right?
n factorial.
Huh? Yes, Jessica, very good.
In fact,
In fact. Yeah, that goes without saying that A and B are of same cardinality. Otherwise, bijection can't be established. A and B should have same number of elements. Only then bijectivity is possible between them. Understood? In that case, number of bijections will be n factorial. Are you clear? So what is the idea? F inverse exists, no? That's why when sin x is defined from minus pi by 2 to plus pi by 2. When we restrict its domain to be this way, and when its natural codomain is this way, what happens? Sine inverse exists, right? Because it's a bijection. If you define sin x this way, it will become a bijection. If you define your sin x as from R to R, it wouldn't be a bijection. So sine inverse will not exist. You understand? That's why we made sin x bijective by restricting its domain to be this and taking its codomain as -1 to +1. We made sin x bijective. So its inverse existed. No? From where? From -1 to 1 to minus pi by 2 to plus pi by 2. Okay, understood? So that's when the inverse functions exist, right? Okay, so let's write for, so this is the domain and this is the codomain. Now, all of you write all these and let me know whether you are okay with this. Then we shall proceed for inverse functions. Okay, let me check. For cos inverse and tan inverse, domain is same. All of you know that. But the range will be 0 to pi. Got this properly? Yeah, these are simple. How about tan inverse? Tan inverse is defined on R, correct? And it's
Open brackets minus pi by
open. Very good. Open minus pi by 2 to plus pi by 2. How about cosecant inverse? So sine inverse is always defined for fractional values. But your cosecant won't be defined for fractional values.
Or minus or minus one.
R minus open minus 1, 1. Okay. And its principal value branch will be same as that of sine inverse. But the thing is, sine 0 is 0, isn't it? That's a danger point. So I have to subtract this. Why? Why? Because if I take that 0 is in the range, if I take that 0 is in the range, I'll get an absurdity here, no? Suppose there is an x for which cosecant inverse of x is 0, then x will be cosecant 0, right? But cosecant 0 is what? 1 by sine 0. So we are in danger. You understand that? So 0 can't be there in the principal value of cosecant inverse. Understood? Similarly, secant inverse also has the same domain. How about its principal value branch? It will be 0 to pi, but we need to subtract
Minus 5 beta.
pi by 2, single set. Okay, what is the problem? Because if secant inverse of x becomes pi by 2, then x will become secant pi by 2, which is secant 90. That is 1 by cos 90 and will be in soup. You understood that? So I'm subtracting pi by 2. How about cot inverse of x? What is the domain? Very good. Okay. The range is tricky. No, for cos and cot inverse. Who remembers? Very good. Open or closed? Open. Very good. Let me know how many of you got this right, because this is very, very important in inverse.
I messed up for last case.
Huh?
I didn't say anything. I messed up for cosec.
Ah.
I wrote somewhat with it. I forgot to subtract
Ah.
the right one first.
Say, get this right. Okay, this is very, very important, because based on this only we have problems. See, inverse isn't coming much, but that can make you lose your 100. No, that's what we are aspiring. So for example, they ask you, what is the domain of the sample problems I'm just giving? For example, they're asking, what is the domain of this? Can you work on it? Anything? X square minus 1 or x square minus 2. I'll make it simpler for you. What is the domain of cos inverse of x square minus 2?
Minus 1 comma minus root 3 union
1 comma
1 comma root 3 union minus 1 comma minus root 3.
put it the other way. Put it the other way.
Minus root 3 comma.
Now it sounds good.
minus 1.
I don't know if the answer is correct, but yeah, I think she is right. No? Did you get it? See, this is arising from what? What did I tell you? If you know this, you know everything in inverse trigonometry. You know that cos inverse of x means x has to be from here. No? Cos inverse operates on something. That something should be necessarily between what? Did you put it this way? After that, you add 2 everywhere. So you get this. You would have got this. Now, up to this is simple, but many students will take only, when they take the root, they will only take between, this only has this implication for them. But actually it has the other implication also. It can also be minus root 3 as well as 1. I'm sorry, minus 1. When you take the negative values, you should put the numbers. You have to swap the numbers. Understood? When you take the square root. So finally, what should you say? Either this is the possibility or that is the possibility. Therefore, you should say that x belongs to 1 root 3 or minus root 3 to minus. Understood this? Okay, I'll ask you another question. Find the domain of sine inverse of x plus cos inverse of x plus tan inverse. Okay, find the domain and range of. Find the domain of this sentence. Range. Okay, anyone? I think she gave the correct answer. Rakshita gave the correct answer.
Domain is -1 to 1.
Yeah, very good. Domain is -1. No doubt. How do you find out the domain of several functions when many functions are present? How do we find the domain? We find the domain of the individual functions and take their intersection. Understood? That's the way to find the domain. Because domain has to be in accordance with, or it should be compatible with everything, right? It cannot violate any of the nature of the function. So it should be, what is the domain of sine inverse of x? -1 to 1. Intersection -1 to 1. Intersection -infinity to infinity. But the intersection of several sets will be the smallest set, right? So the domain will be -1 to 1. Are you all clear? How about the range? Range. Do you all know the simple fact that these two actually add up to pi/2? Do you all know that? Therefore, what will be the range?
Tan inverse x.
Ah, very good. Yeah. Tan inverse range is pi/2 to minus
Yes,
pi/2
pi/2.
plus pi/2,
Yeah.
right? So the range will be pi/2 plus minus pi/2 for minimum. Okay. So minimum of the function will be pi/2 plus minus pi/2, because minimum of tan inverse is minus pi/2, right? So 0. And the maximum of f will be, what is the maximum of pi/2? That is pi. So what is the range? Let me see who is intelligent. Therefore, what is the range?
0 to pi open.
Aparna said correctly.
0 to pi open.
Open. Because even though I put minus pi/2, this minus pi/2 is not assumed by tan inverse. That is open. So your final range should be open. Okay. How many of you got this correct? Let me see. Intelligent ones. Very good. I know Sri Lakshmi can do it. Yeah. 0 to pi. Anirudh also. Right. All of you understood how to find the domain and range. Okay. Okay. Now let us see if we can do a simple problem like this. Something like this. Can you bring it to its legitimate value? You got it?
Sine inverse of sine, we assume it as x, is always going to be x.
Not always. Not always. It should be in that principal value branch.
And we have to separate it based on branch, right? So
Tell me, what is the range of sine inverse? It has to be there.
minus pi. No, it's on -1.
First, you are right. Minus pi/2.
Minus pi/2.
Minus pi/2.
It has to be brought to that interval. Otherwise, it is not correct. Pi/?
And pi/5.
Okay. What is the best method of doing it? Let me see who is helping me.
And split it as 30 plus 1.
One way of doing it, Aparna, but there is
5 plus 5, pi/5.
Huh? I
Just 5 plus
gave you
5.
all a very simple method. These sine function or cos function, whatever, you can subtract any even multiple of pi from them. If it's positive, subtract even multiples of pi. If they've given you a negative argument, add. Okay? Add even multiples of pi. But be careful, only even multiples of pi are allowed, like 2 pi, 4 pi, 6 pi. If you add anything else, it will be absurd. Okay? So what is this? This will be useful in MCQs. That's why I'm saying. 31 pi minus 30 pi. Understood, all of you? That's the simplest way of getting some legitimate value in the range. What is pi by 5? All of you know 180. No, 180 by 5, 36. Fine. Isn't it? Because the principal value branch is minus 90 to plus 90. So this is fine. Understood how to get. Okay, let me test one more sine inverse.
Ma'am, can we
Tan
split
inverse.
it as 6 pi plus pi by 5?
That's what she was saying. Yeah, you can. You can do that as well. Minus 41 pi by 4. Can you try this?
Is it minus 1?
What did you get?
Minus 1.
Minus 1, is it? No, but you should get
Minus pi by 4. No?
yeah,
Minus
it's correct. That's what you must have got. You are saying the wrong answer, but you must have got it right. What are you planning to do? What did I tell you?
Add
When there's
10
a
pi.
negative
Add 10 pi.
argument. Add 10 pi. That's a brilliant move. Understood, all of you? Understood why I'm adding 10 pi? Because that's very close to what's given. Considering that 4 is there, 4 into 10 is 40, which is close to 41. So that's what I'm doing. So tan inverse of tan of minus pi by 4. And I know that minus pi by 4 is legitimate, no, because it belongs to open. Minus pi by 2 to plus pi by 2. Understood? Okay. Now, another important aspect of inverse trigonometry is to establish how one is connected to the other. So, can you fill this? What is sine inverse of x in terms of cos inverse of something?
Root of 1 minus x square.
Very good, very good. You got it right. Look at this. Look how fast he is doing. Sine inverse of x is some theta. It will be always theta, right? It will be some angle, right? So what is x? Sine theta. This seemingly simple trigonometric equation has an implication, a pictorial representation. Sine theta is x. What I understand is that sine theta is x by 1. That's what it means. This is what is actually should be expanding before you. Whenever you see sine theta as x, you should draw a picture. All of you understand? Sine theta is x. So you should draw this picture. So what is the adjacent side, you tell me? Minus x square. So cos inverse of what? Adjacent by hypotenuse. So root of 1 minus x square by 1. Tan inverse of what?
X by root over 1.
X by root of 1 minus x. What is it in terms of cot? It will be adjacent by opposite. What is it in terms of secant?
Basically 1 by
Hypotenuse by,
root of 1.
hypotenuse by adjacent. What is it in terms of cosecant? Hypotenuse by opposite. Okay. So we also come to know another relation. Sine inverse of anything is cos inverse, cosecant inverse of. No? Understood, all of you? Of course, it should be in the valid domain. Yeah, x should be between minus 1 and plus 1. Only then all these things will be valid. Followed, all of you? Okay, what else is? Okay, we'll take the case when it comes. Now, coming to the matrices and determinants are very important from the point of view of MCQs. They trap you, okay, in MCQs. So, let us take some important aspects of matrices and determinant. What is the determinant of a diagonal matrix? Can you tell me? What is the
zero.
determinant of a diagonal matrix?
Is it 0?
How?
Yes,
What is
zero.
a diagonal matrix?
Zero.
Who remembers? Elements along the diagonal? What is the diagonal matrix? You forgotten, no? Don't tell me
All
that.
the non-diagonal entries are
Oh,
0.
very good. All the non-diagonal entries should be zeros, no? For
Will
example,
it be the sum of the diagonal entries?
will it be sum or the product?
Product.
Product, ma'am.
See, do you all agree it's diagonal? Yes or no? This is a diagonal matrix. No. What is its determinant? I'm asking. So it will be what?
Is it
Product of diagonal entries. Get this right. The determinant of the diagonal matrix will be always the product of the diagonal entries. This is first thing. And determinant of a scalar matrix. What will be that? Will be?
n cube?
Very good. It will be equal to k power n. If A is n by n and the diagonal entries are filled with k. Do you know scalar matrix is nothing but what?
All
What is scalar
diagonal
matrix?
entries are equal.
Equal diagonal entries.
Very good. Equal diagonal entries. That is what is called a scalar. Understood? So if it is 3 by 3, it will be k cube. Okay. If it is n by n, it will be k power. Understood? If it is 2 by 2, it will be k square. Next. What is the determinant of a singular matrix?
It's, 0.
Huh? I didn't
Zero.
hear.
Zero.
Zero. Very good. Singular means 0. Okay. So note, the determinant value of singular matrix is 0. Therefore, singular matrices will not have. Very good. Singular matrices do not have inverses. So when is a matrix invertible? Only when it is not single. Non-singular matrices only can be invertible. Understood? Okay, next one. Some properties. What will be the determinant value of A transpose?
Determinant of A.
Very good. It will be always the determinant of A. If you transpose a matrix, its determinant is unaffected. We all know this. Okay.
You're changing the order of the rows and columns.
Yeah, just making the rows become columns, columns become the rows, so that it won't impact the determinant is well known. Okay. So determinant of A transpose is the same as determinant of A. Are you all okay with that? And similarly, the implication of multiplying a matrix by a scalar.
With k power n into determinant.
K power n into determinant A. If A is what? N cross. Correct? Okay. Note down. Note down all these. These are important MCQ points. Okay. And then we'll have a J. There is an important property of that J. What is it? When I multiply a J with A, what will it?
Determinant A.
Determinant A into I.
I'll get a scalar matrix.
Determinant A.
I'll always get a scalar matrix. A scalar matrix in which along the diagonal, I find the determinant value. Okay. So if they give you, sometimes they give you problems like this. A into a J is given by 25, 0, 0, 25. Okay. So what have they given you? What is this 25?
Determinant.
Determinant. Understood? So they test whether you know this property by giving a scalar matrix like this. But this is nothing but 25, I know. You understand? Therefore, determinant A is nothing but 25. It's a very indirect way of presenting your determinant. Understood or not? Okay, next one. What is the determinant of a j?
Determinant of a power n minus 1.
Determinant of a j will be the same as the determinant of cofactor a. Both will be equal to determinant a power n minus 1. Because cofactor and adjoint, how are they related? Transpose.
Transpose.
Okay, therefore, the determinant of aj and determinant of cofactor a will all be same. Okay, what will be the determinant of adj of k? What is, just think of this, what is the
K power n
determinant
minus
value?
1.
K to the power
Somebody said correctly. Jessica, what did you say?
K power n minus 1 determinant of a. No, wait.
K power
I
N
think
minus
it's
1
wrong.
determinant a power n minus 1.
Determinant.
What is adj of x? First you tell me. What is adj of x?
Determinant of
Determinant
x
x
power
power
n minus 1.
n minus 1. Do you all agree?
K to the power.
But in place of x, I have ka. So determinant of ka raised to the power n minus 1. But what is determinant of ka? K power n into determinant a raised to the power n minus 1. Understood? Simplify. I think this nobody gave. So this will be k into determinant a power. Okay. Next. 9th one. What is adj of aj in terms of the matrix A? Does anyone know?
Determinant a power n minus 2 into a.
Very good, Anirudh. Thank God. I don't know how he knows. Is it possible for you to prove this, Anirudh?
No, ma'am, my memory is.
Okay, but I think we can attempt it. Why not? I know the result, but I can also attempt the proof. How do I find this? Can anyone tell me what is this? Consider. Consider aj into adj of aj. That will be equal to
modulus of
x into adj of x. Who remembers? What is x into adj of x?
determinant of x into I.
So x is
Very good. Determinant of x into I. Do you all remember that?
Yes.
Okay. Therefore, instead of x, what do I have?
A.
Aj. Aj. Therefore, determinant of aj into I. How many of you understood this one? I merely applied what? This result only. Okay. Till then, whether you follow or not, tell me. After that, we'll proceed. You are okay with that? Okay. In the next step, what should I do? In the next step, what can I do?
Determinant of
You can
aj.
create determinant adj in terms of
Good
determinant.
job. Yeah, that's a good idea. So he says on the right side, on the right side, on the right side, I can fill it up as determinant of. Yeah, that's a good idea. Because I know what is determinant of j, right? That's nothing but determinant a power n minus 1. What can I do further to resolve this? I want this. I want a workable solution where I'll be able to establish what this will be. Multiply by
What's its square?
multiply 3 multiply by a. That's what I was thinking. A into aj into aj of aj. Is it okay? After that, what is A into Aj?
Determinant A.
Very good. Determinant A into I. Okay, determinant A into slowly we are proceeding to what Anirudh said. What is A into I? A only, no? Okay. What do I do afterwards? Yeah, this I into this will be simply that, no? Adjust, Aj. And shall I take this determinant A to the other side? Established, no, Anirudh? This is the proof. That's what he gave. Remember it as Anirudh's result. Aj of Aj is determinant A bar n minus 2 into A. Okay, so what is the determinant of Aj of Aj?
Determinant of A n minus 1 the whole square.
Very good. Very good. Aman. N minus 1 the whole square. Perfect answer. So maybe you can remember it as Aparna's results. Understood how? The proof is simple. What is Aj of X? Determinant of Aj of X is determinant X bar n minus 1. Okay. And therefore, Aj of Aj will be what? Determinant of Aj bar n minus 1. That is determinant A bar n minus 1 power n minus 1. That is determinant A bar n minus 1 the whole square. That's a perfect answer. Understood all of you? Everything is arising from this only, no? Have you copied? Okay. How about Aj of B into Aj of A? This will be equal to
Aj into Aj.
Hmm.
Wait, sorry.
That will be Aj of
Aj of AB.
very good. Reversal law. From this only we get what? This B inverse into A inverse is nothing but AB the whole inverse. Okay. And something similar looking is this. B transpose A transpose. Remember what is it? AB the. All these are examples of how reversal law works. Okay. What is the determinant of A into Aj? Who remembers?
Determinant A,
Determinant A power n.
sorry.
Because always remember, if you have determinant of the product, it will be product of the determinant. Okay. Determinant of the product is product of the determinant. Therefore, determinant of A into Aj will be equal to determinant of A into determinant of Aj. Right? But determinant of Aj is determinant A bar n minus 1. So this will be determinant A bar. Okay. What is the determinant of A inverse?
One by determinant.
Very good. 1 by determinant A, provided determinant A is not 0. Because that is the condition, no, for inverse to exist. What else? Aj of A inverse will be equal to Okay, this one. Adj of A transpose will be equal to Adj the whole transpose. Understood?
Yeah.
Adj of A transpose is therefore A inverse transpose will be the same as A transpose the whole inverse. Okay, okay with this. Just now I thought of something.
You were saying a
Ah, ah,
A
ah, ah.
inverse.
Yeah, Adj of A inverse. That will be equal to Adj the whole inverse. The combination of these two.
Yeah.
Okay with these. Okay. And then about symmetry. About symmetry. A is symmetric if there are two ways of looking at it, no? Whenever Aij is Aj for all ij. There are those who define it like this. That's also fine. Or you can define it as A is symmetric.
A is
If-
equal to A transpose.
A transpose is equal to.
Yeah. That is a simple way of defining it. A transpose is A. Next, A is skew symmetric if Aij is
Minus AJ.
minus Ai for all ij. You can define it this way, or you can define it as A is skew symmetric if and only if A transpose is minus. What is an important result concerning symmetry and skew symmetry? Every matrix can be, every square matrix. Okay? Every square matrix can be established as, can be written as
Sum of skew
Sum of-
symmetric and symmetric.
sum of a symmetric and a skew symmetric matrix. It's a very important characteristic of square matrices. That is established by, that is proven by writing A as half of A plus A transpose plus half of A minus A transpose. Do you all remember this? So this is the way how every square matrix is written as a sum of symmetric and a skew symmetric matrix. So this can be established to be symmetric, whereas this one can be established to be skew symmetric. And then the diagonal entries of a skew symmetric matrix will be
Zero. Zero.
very good, will be always 0. All the diagonal entries have got to be 0. Otherwise, they can't satisfy the property that every element is negative of its image. So AII must be minus of AII. No, that is possible only if 2AI is 0, or when all the diagonal entries happen to be 0. That is for skew symmetry. Understood? Similarly, how about the determinant value of a skew symmetric matrix? If determinant A will be 0 if A is skew symmetric of what order?
Same order.
Huh?
Second order.
Second order. Second order. See, for example, I take a second order.
Third order.
Third order. Or any odd order. Minalini, I'm taking this. Okay. Do you agree that it is skew symmetric? All of you agree?
Yes.
The diagonal entries are zeros. Non-diagonal entries are negative images of each other. But how about its determinant value? 0 minus of minus 4. But that's not 0. Did you see? So skew symmetric, just because it is skew symmetric, its determinant value need not be 0. But if it is skew symmetric and odd order, that is when determinant will be 0. Okay. So complete this. Determinant A will be 0 if A is skew symmetric of odd order, any odd order. They may ask the proof of this. This proof was asked for 2 marks once. Okay, how do you prove it? What is the characteristic of the skew symmetric? Let me see who remembers. How do you define a skew symmetric? A is skew symmetric, implies A transpose is equal to
minus A.
minus A. Okay. So now we are bothering about its determinant, isn't it? So apply determinant on both sides. Apply determinant on both sides. So determinant of A transpose is determinant of minus A. Do you agree? But we have seen that the determinant of A transpose is nothing but determinant A, isn't it? If you transpose, a transposition will not impact the determinant value, right? So determinant of A transpose and determinant A are same. How about this? This has to adhere to that law. Determinant of Ka is K power n into determinant A. Do you all remember this? So what is minus 1 into A? You know, that will be minus 1 power n into determinant A. Do you agree? So this has got to be minus 1 power n into determinant. But what is n here? N is odd or even?
Odd.
N is
Odd.
odd. So what will be minus 1 power n?
Minus
What is minus 1 raised to an odd power?
Minus 1.
minus
Minus
one.
one. Yeah, it will be minus 1. So determinant A will be minus of determinant A. So what will be that? 2 times determinant A is 0. Okay, therefore, determinant A is, you understand? Hence, can you copy down this proof? Copy down. I have jotted on all the properties in some place. Let's see. I don't know if I left something. Idempotent and all that. Okay, this was from JE class. So I don't know if you require all that. Orthogonal, all that. I don't think anyway, so I think the only concept that you require right now would be that of area of a triangle. Remember? I think that's there in determinant. No? Area of the triangle. Who remembers? Modulus of
X1, Y1.
x1 into y1 minus. Okay. So let us not write this. So let us put it as determinant itself. Remember all of you? I think we can write this as x1, y1, 1,
X2,
x2,
Y2,
y2,
1,
1,
X3, Y3, 1.
x3, y3, 1. Okay. So sometimes, you know what they do, they give you the area of the triangle and they ask you to find out K. That can come for 2 marks. So that is, there is a trap there because there is a modulus. When you release the modulus, you won't put plus or minus. That's why they're asking that question. So be careful. No. Yeah. Okay. Yeah, please call me after 1. Okay. So this is the area of the triangle. Understood, all of you? I think we have covered all the possibilities, but we are running out of time as usual. So shall we see the paper? Because vectors probably I can combine with, because I thrust so much on you today. So just we'll discuss all these very fast. Are able to see, or should I zoom it a bit? Are you able to see? Okay, what's your choice for the first one?
B, ma'am.
Modulus of 3.
Huh? Which one?
A. Inclusion of modulus of 3.
Ah.
3 is positive.
No, it's congruent. Congruent. X is congruent to y modulo 3. Meaning, mod of x minus y is a multiple of 3. That one. Yes, post it in a different way. X is congruent to y modulo 3 means when x is divided by 3, it leaves the remainder as something like that. So x minus y is a multiple of 3. That's what it means. The statement says x when divided by 3 leaves the remainder as y. So x minus y is a multiple of 3. That's what. But you know, this is a very popular equivalence relation, isn't it? Modulus of x minus 1, if it's a multiple of 3, then it's an equivalence relation, definitely. I think this is also good equivalence relation. This is also an equivalence because it's mod of x minus y is 2k. All these are equivalence relation. But this wouldn't be equivalence. Why?
Symmetry will not be followed.
Not symmetric.
It wouldn't be. It wouldn't be symmetric. Yeah, not symmetric. Understood? These can be just by inspection you can do. No, these can be done fast. Which of the following is a bijection?
C.
Good. Good, Jessica. Very good. Yeah. See, even this wouldn't be bijection. You know what? Because all the
And just odd numbers.
images, all the images are odd. So the range is odd integer. Range of this will be set of all odd integers like -3, -1, +1, 3, 5, like that. All odd integers, but that wouldn't be equal to the codomain.
A and B are
Understood? So this wouldn't be a bijection. How about this? What about the range of this? It will be 0 plus. It's not interval. It's not interval at all. Okay. The least that you can think for x square is 0, isn't it? So 1. Next one.
C, ma'am.
It can be 2.
2.
2 also.
Can be 2. After that, 3. 3 square. 2 square. 2 square plus 1. 3 square plus 1. You know what? Many students write the range of this to be 1 infinity. But that's not the case when the domain is Z. No, many students go wrong. Mind it. The range is not 1 infinity. The range is discrete set 1, 2, 5 because your domain is discrete. No, domain is separate. So how can the range be an interval? Range can't be that. Understood? So this is not. How about this? Definitely not. Okay. Because the range will be all the plus or minus 1, plus or minus 8, plus or minus 27, all these. Understood? I'll send you this paper, don't worry. Next one. Okay, can you try the third one? Let me see.
C, ma'am.
What did you get, ma?
5/4.
5/4, is it? Okay, she can be right.
Pi by 4.
How did you get, Anirudh?
I applied the 2 tan inverse of x formula, 2 cos square x by 1 minus cos square x and equated it to 2 cos x.
2 tan inverse of x is tan inverse. All of you know this formula? All right. That should be equal to tan inverse of, this should be equal to tan inverse of 2 cosecant x. What is 2 cosecant x? 2 by sin x, no? 2 cosecant x is what? 2 by sin x. That's equal to 2 cos x by sin square x. So assuming that x is not 0, maybe I can cut this. So cot x becomes 1. Cot x is 1. So x must be 45. Correct. Both of them are correct. Next one is simple, no?
5/6.
How many of you got that? 5/6. Okay. So listen, in case you find secant inverse to be, a little bit difficult, write that as cos inverse of half. Then it'll be easy for you. Understood? Plus sin inverse. What is cos inverse of half? Who remembers? 5/3. 60. No? 60. So 2 pi/3 plus sin inverse of half is 30. So pi/6. 6 is LCM. So 4 pi plus. Very good. Correct. Solve this.
A, ma'am.
Yay. Huh? All of you got it. I also got it. Okay. Then try this. I was trying to do mentally.
C.
I think she got it right. I get something else. Correct. Yeah. How many of you got this? Will it be a matrix or a number? It will be a matrix, ma.
Matrix.
Because you are multiplying two matrices and adding. So it will be a matrix only. It will be 1 by 1, no doubt. AB is 1 by 1. XY is also 1 by 1. Okay. AB is actually 6 minus 6 plus 8. So 8 plus this one is 2 plus 6, 8 plus. So she is right. No. Understood. You shouldn't write this. Don't be carried away. 28 is the answer, but it should be a matrix. Next. Why is it taking long?
Is it 2AB?
Got it? You got 2AB. Oh. I'm thinking B is AB, right? So what is B into B? It will be, say, I pre-multiply by B.
No, ma'am, it's 2B corrected.
Understood? So your B square is B. Similarly, we can establish A square is A. How many of you got A? Did anyone get A? No? It's simply associative law. Remember, associative law holds good for matrix multiplication, but not commutative law, isn't it? AB is not equal to BA in general, but A into BC will be always equal to AB into C. Okay? This is just testing associativity. Clever question.
X is equal to 8, Y is equal to 8.
X equal to 8 and Y is equal to 8.
Yes.
That one?
Yes.
Oh. How many of you got that? It seems she got this. I tried doing it mentally, gave up. A square, what did you get? Can you read out?
16, 8, 56, 32.
I'm just testing, Apana. You are giving distance. 24, 8, 56, and 40. Right hand side is 80. Perfect. It's coming. I think we can do trial and error actually, no? If we just find a square, substitute the values of x and y there instead of attempting to find, say. Okay. This is clicking. Are you able to read? A is a 3-row square man, 3 by 3. 3 by 3, determinant A is 4. What is edge of edge A? Whose result is this? Anirudh result. Anirudh's result. Remember what he said? What is edge of edge A? He gave a result, remember? What is it? Determinant A power n minus 2 into A. Right? What is n here? 3. No? So determinant A power 3 minus 2 into A. What is determinant A? Determinant A into A. That's what it is. Which option? C. Okay with the results? Assertion. Sine inverse of minus x is minus 5. No? Minus of sine because the principal value branch lies in the fourth also. It's a bijection map. What do you think?
It's not explaining.
B.
B. A square is Ka minus 2i. See if it's correct. Can you first find A square? See, do very quickly in the exam, okay? Don't be staring at the problem.
My assertion is false.
Assertion is false. False, is it? Can you tell me A square, Aparna? What did you get? A square.
1
Ah.
minus 2. 4 minus
Minus?
4.
Did you all get this? Okay, that is equal to K value is given as minus 1, isn't it? So minus 3 plus 2 minus 4 plus 2, right? Ka minus 2i. Ka, oh yeah, no? 2i is this, correct? That is turning out to be minus 5 to minus 4. Yeah, something else. False. Fortunate. I was thinking how to say whether it's A or B in case it's right. Anyway. Clear cut. No? Okay. So which option? D. Be careful. Okay. Sometimes you choose C by mistake. If A is a 3 by 3 non-singular matrix, see if it's correct.
D, ma'am, not correct.
Which one you said?
D, ma'am, option D, A is not correct.
A is false, is it? Oh. Why, Anirudh? I thought it was right. What is the left-hand side? What is the determinant of the product? Product of the determinants, right? Do you all agree? What is determinant of A inverse? 1 by determinant A. What is determinant of a J? Determinant A square. So is it not determinant A? Why did you say that, Anirudh? Right, boy?
I didn't see it, so it was 3 cross 3. I thought it was n and determinant
Oh.
minus 2.
Okay, okay. But he has given. It's correct only. It's correct only. And this is also correct only.
Because where did B come in?
Yeah. There is no inverse concept here.
Yeah.
We just use that mod of xy is mod x into mod y. That's what we used. We didn't use this concept. Okay. Can you just finish this and go? Okay, give me counter examples for all these. Who's going to say? First one. Who's ready to establish that it's not symmetric, that's not reflexive? R. Half is not less than half square. Okay. So half does not belong to R. Okay, next one. For symmetry, who's ready?
2 and 4. 2 and 4.
2 and 4.
Because
That will come actually. 2 is less than 4 square, 4 is less than or equal to 2. Equal to is allowed.
Okay. But it's not the same thing, right? 2 and 4 are not the same thing, right? Wait.
We should take only the basis.
2 is not equal to 4.
See, 2 is less than 4 square is correct.
Okay.
4 is less than or equal to 2 square is also correct. No, that's not a counter example.
Okay.
We can say 8 is less than or equal to 3 square, but 3 is less than or equal to 8 square, less than or equal to. Not this. Give me. Huh?
1, 2, 2.
Which example? 1, 2 and 2, 1. 1 by 2 and one more number you should take. One single number won't do, isn't it? See, 1 is less than 2 square is correct. 2 is less than 1 square is false. Therefore, 1, 2 belongs to R, but 2, 1 does not belong to R. Therefore, it's not symmetric. Transitive, can someone tell me? 2,
1, 2 and 4.
No.
We can use what we already have, right?
1 is 1, 2 to 4.
1, 2, 2, 4.
But it will be true. 1, 2, 2, 4.
4
belong to-
less than or equal to 1.
1. 1 is less than 4 square is correct. No. Don't take this, something else. Who's ready?
Ma'am, 8, 3,
8, 3,
3, 2.
3, 2. Correct.
Keep taking a
Big shot. She's taking a big shot. Take it as close to that as possible. It's square. 8 is very close to 9. No? That's why she has taken 8. Good example. Copy that.
Less than or equal to 1 square.
Correct.
So we couldn't have.
No, 1 only you said no on the left.
Okay, the order which I took.
Order it counts.
But if I took it as 4, 1, then only it would have made sense. So
You could have taken 4 to
2 to 1. That
4
was
to 4, 1, 4 to And then 2, 5, 2, 5.
You can take anything.
But 4
as
will be
minus-
less than 5 square. No, you can't take that.
5 square is not less than, no, sorry.
4 is less than 5 square. Correct.
Okay.
That's not an appropriate counter exam. Anyway,
Five
this
is
is
not
worked
less
out.
than 2 square, so
5 is not less than 2. You can take it that way. So you can keep 5 in the first place, 2 in the last place, in between anything that can form.
it can.
Okay, could you prove that it is 1-to-1 but not onto? Who's ready? F of n is n square plus n plus 1. You have to prove that it is 1 but not onto. Who's ready?
Upon factorizing, it comes out to be x1 minus x2.
Yeah. F of n1 is equal to f of n2. So n1 square plus n1 plus 1 is equal to n2 square plus n2 plus 1. Plus 1 cut. n1 square minus n2 square plus n1 minus n2 is equal to 0. Then, because we need to prove it to be 1-to-1, so we have to go straight way. We can't give counter examples. That's the drawback. So we have to prove it this way. The test for 1-to-1 assignment. So either n1 is n2 or n1 plus n2 is minus 1. So the question may arise, why are we coming across two solutions here? Because 1-to-1 is, it's against 1-to-1, right? When you come across two solutions. But then our argument is that
It is a natural number.
this is impossible, right? Impossible. In what?
The domain
In the
is
domain.
natural
Very good.
numbers.
Yeah, she used the correct word. In the domain, it is impossible. Because the domain is natural numbers. So sum of two natural numbers can't be minus 1. So this is the, what should you say? Only solution. Okay, therefore it is 1-to-1 is established. Now I have to prove that it's not onto. Is it onto or not? N square plus n.
No, they're asking us to prove onto, right?
It's
Why didn't you want?
It is 1-to-1. We have established that. Now we have to prove that it's not onto. Okay, who is ready?
Take f of n as 1.
Very.
Two results if we factor.
Yeah, very good. Or else I can find the range, no? The range is very straightforward because n belongs to capital N, right? So n assumes only natural numbers like 1, 2, 3, etc. So I get the first value to be 3, second value to be 4 plus 2 plus 1, 7. And then next value to be 9 plus 3 plus 1. What is it? 13 and so on. So that's having gaps in between. It's not the entire n. Not equal to code. Yeah, not equal to code. Therefore, not onto. We established that also. Okay, but here is given clear-cut instructions here. But even if we were to guess, I'm sure we will proceed in this way. Supposing if he says investigate whether it is 1-to-1 and onto, I think you have to go the straightforward way, right? Otherwise, you will be guessing what, like he guessed that it can't have pre-image, or you can say that there are two things which have the same image. But I think we can't make some guesses here. So it's better to establish, you see, established tests. Who's ready? Next one. Write in the simplest form. Okay. Sine of 2 times tan inverse of root of 1 minus x by root of 1 plus x. Sine of 2 times tan inverse of root of 1 minus x by 1 plus x. Who's ready?
X is cos 2 theta.
Cos theta. Sure short substitution which will work. Always remember, when you have, I think I've given you these clues already. We have 1 minus x square, put x as sine theta. Okay. If we have x square minus 1, put x as secant theta. If we have 1 plus x as well as 1 minus x, then put x as cos. This will only work sure short. if we do not have the root there, then it is worth substituting tan. Understood? Okay, take down these clues. This will help you in resolving most of the inverse trigonometric arguments when they give you in terms of algebraic functions. You need to substitute in terms of trigonometric functions, right? So these are the ones that will help you. Suppose if it is x by 1 plus x square, something like that. What will you say?
X as tan theta.
Says tan theta will work. X by 1 plus x they gave. What can you do? Tan theta is working. I think in that case, it's better to construct the triangle and do it, I think. But in this case, because we can, in this case also we can construct the triangle and do, but because it is clicking right now, what is it? 1 minus cos to theta by 1 plus cos to theta. Got it. Very good. Tan theta. What is it? You have to express in terms of x. Very good. Root of 1 minus cos square to theta. That will be the final answer. Followed. So she brilliantly said, whenever under root 1 minus x and 1 plus x are there, definitely what will work? Yeah, so some more. Sin theta by 1 plus cos theta. Who remembers? What is this? Some of the conversions that will help.
Numerator will be 2 sin theta by 2.
Very good. You have to write this as 2 sin theta by 2 cos theta by 2. And 1 plus cos theta, you have to write as 2 cos square theta by 2. So it will be tan theta by 2. Okay. So they may give you several expressions like this, expecting you to simplify. That's why I'm telling you. Suppose they give you sin theta by 1 minus cos theta. What will be that? Tell me. Mentally you do and tell me.
Cot theta by 2.
Cot theta. Yeah. So if it is 1 minus cos theta by 1 plus cos theta, what is it? Do it mentally. Tan square. So if it is 1 plus sin theta by cos theta, who remembers? 1 plus sin theta by cos.
Tan of 4 plus theta by 2.
Very good. We got it, I think. 1 plus sin theta can be written as sin theta by 2 plus cos theta by 2 whole square. Do you all remember? And cos theta can be written as cos square minus sin square. So that sine theta by 2 plus cos theta by 2 will get cancelled. I will get 1 sine theta by 2 cos theta by 2 retained in the numerator. And so it will be sine theta by 2 minus cos theta by 2. That's what will remain. If I divide throughout by cos theta by 2, this is what I get. That is nothing but tan of, that's what you said, no, Anirudh, if I heard you right. Is that correct? Will you remember this? Huh? All these are perfect squares. That's what you should remember. 1 plus sine theta, 1 minus sine theta, 1 minus cos theta, 1 plus cos theta. All are perfect squares. This will be 2 sine square. Take down. These 4 are very important. 2 sine square theta by 2. This is 2 cos square theta by 2. This is cos theta by 2 plus sine theta by 2 whole square. And this one will be cos theta by 2 minus sine theta by 2 whole square. Okay.
We can directly use these results, right, ma'am?
Yeah, you can directly use it.
Okay.
If some algebraic function is given, then you should think of suitable substitution. Okay. But if it's already trigonometric, you have to use all these. Okay. Apart from this, what will work is sine theta, which is 2 sine theta by 2 cos theta. I hope you jotted this down as well. Right. So they can give you anything involving these. Okay, can you just finish this? 16. 16. Evaluate tan of half of sine inverse of 3 by 4. Can you try? Tan of half of sine inverse 3 by 4. Am I right? Half of sine inverse of 3 by 4. What is the question? You need to find this, no? Find. So tomorrow.
Is it a 4 in the denominator or 5?
Why you want it to be Pythagorean triplet?
Yes, ma'am.
16 minus 9. Root 7. How are you trying? It can be based on this sine inverse being an angle. All of you know that this is an angle. You can start from there. Understood? It should be an angle. So consider it that way, which means that 3 by 4 is sine theta. So This should unfold immediately. You should get the angle, triangle right. Once this is established, what is occurring here is tan of half theta, isn't it? Or in other words, tan of theta by 2. Okay, who remembers what is tan of theta by 2? We did it. We did it. You only said.
Yes.
Huh?
1 minus cos theta by 1 plus cos theta.
Ah, yeah. Where did we do?
1 minus cos 2, wait,
Huh?
cos.
Below. Not here.
1 plus cos 2.
Ah, here. Here. Ah. From here. 1 minus cos 2 theta by 1 plus cos 2 theta is tan theta, right?
Yeah.
Ah, here. So. Tell me what is cos theta from the figure? What is cos theta? Adjacent. I hope you can simplify. Was it difficult? It isn't difficult, provided you understand that every inverse trigonometric function actually depicts an angle. The idea arises from that. And after that, of course, you need some trigonometric formulas. So probably, can you take a screenshot? It may take a while for me to send this to you. So can you take just the screenshot of this, and after that you can try. And section C has some problems relating to bijection. Yeah. I have to dig and find out where the solutions are, because I think this is one of the old papers that I gave. Take a screenshot of this also. This is some case study. Okay. Again, bijection. This is for 5 marks. X by 1 plus mod x. I think solve using matrix method. See, in this section, you have 2 5-mark questions. And you should be doing this flawlessly. That's very important. Okay, so tomorrow shall we have a class?
Mom,
Is it- Yes. Apan.
mom, that 1 by mod x question, can we do that once?
Yeah, that's a tricky question actually. So
Yeah.
she's asking for clues probably. So here, your f of x is x by 1 plus mod x. But you have to split it and write it as, because mod x behaves differently, no? For x more than 0 and x less than 0. Understood, Aparna?
Yes, mom, I got
Sure.
up this.
Yeah, split like this. And then establish one-to-oneness. And after that, try and find the range. The range for this can be found by assuming that your f of x is actually y by 1 plus x. So if you cross multiply and get x in terms of y, you will get the range. And similarly here also, assume f of x is y y is x by 1 minus x. Cross multiply and get x in terms of y. So that way again you will get the range. So unify them, you get your entire range and see if that is the same as this. I hope you can do this, or else I'll send you the solution.
Ma'am, I got the range as y not equal to -1 and y not equal to 1.
Y is positive, right?
Yes, ma'am.
Here is the trick actually. X is positive, no, Aparna. You understand?
Oh, yes, ma'am.
That is the trick. Understood? I'm
Yes.
making the denominator positive by multiplying by 1 minus 1. Or y into 1 minus y is less than 0. So which means that y belongs to 0.
Okay, ma'am. Got it.
And similarly, we can establish for this one, if we cross multiply, we'll get y minus xy is x. Or x into 1 plus y is y. Or x is y by 1 plus y. But consider the fact that x is less than 0. In this part of the definition, x is less than 0. Or in other words, y into 1 plus y must be less than 0. So that is possible only if y belongs to minus 1. So unifying these two, you get the range. The range has to be, therefore, what he has given. The unification of these two will be what? The unified interval, -1 to +1. Understood up and down? Okay.
Yes, ma'am. Got
Yeah.
it.
But that's a tricky question, I know. Understood now? Okay, so can you all do this without mistake? Have you tried it? You have done, any number of numerous problems. So I hope you are fine at it. Anyway, test and see whether you're able to crack it within 5 minutes. That's going to be important. Okay. So can we meet tomorrow? Is it possible? So because we didn't do vectors at all for the dearth of time, so probably we can do vectors 3D tomorrow. Vectors 3D. Is it realistic? Can you finish vector 3D? And also continuity and differentiability. Possible?
Before tomorrow's class.
And applications? Not possible.
Not possible.
Okay, at least these three. I'll test you in this thorough tomorrow. Okay. After that, maybe applications we can combine with the LPP. What do you say? He's a chota bacha, no? So applications and LPP for Monday and Tuesday, probably whole of integration. Oh, we'll run out of time, I think. No? Anyway, try and complete this tomorrow. I'll roast you tomorrow in this.
Roast?
All right?
Roast?
Tomorrow 5 o'clock.